Unit 6 is reactions and stoichiometry. So the chemical equations are the process by which substances actually change. It represents the identities in the amounts. So we use formulas and numbers to show who it is and how much of it's being used. Now it's the process by which substance actually change. So it's a chemical change. There are 4 indicators of a chemical change, and you should know these from Unit 1. Color change. Color change would indicate we have formed a new substance, so that would be a chemical change. Change in energy. So endothermic or exothermic. A change in energy indicates that there was a change in substance. You could form a precipitant. PPT is the abbreviation for precipitant, and that is simply a new solid, so a solid that wasn't there to begin with. If we're using or doing an experiment, the way we actually see that new solid a lot of times is that you'll see cloudy solution, a cloudy liquid. It looks cloudy. You could also form a gas. And when we do a reaction, if we form a gas, we're actually going to see bubbles. Sometimes you may have a smell associated with it, but not always. Characteristics of a chemical reaction: it must represent facts, so you can't make things up. It must be the correct formulas, so you need to make sure that you cross your charges. And it has to satisfy the law of conservation of mass. The law of conservation of mass means that the mass that you start with has to equal the mass that you end with. So you cannot create or destroy mass. It has to be conserved. It has to be the same. And we're going to show the law of conservation of mass by balancing our reactions. When we write a reaction, there's several symbols that we can use. The arrow means yield, produce, makes, forms, turns into, becomes, decomposes into, is synthesized into. There's lots of different words we can use there, and it just means that you're going from your reactants to your products. So the things that are on the left of the arrow are always reactants, and the things that are on the right of the arrow are always our products. A gas is symbolized by a lowercase g. If the gas is a product, then we can also use the up arrow. The solid is represented by a lowercase s, and if it's a product, we can use the down arrow. L is for liquid. Sometimes you might see that L written as a lowercase cursive l. And AQ is the aqueous state. An aqueous state means it's dissolved in water. So water is not actually aqueous. Water is typically a liquid. Now if we wanted water to be a solid, we would call it ice. If we want water to be a gas, then we would call it steam or water vapor. So when you just see the word water, that's typically water as a liquid. Again, water cannot be aqueous because aqueous means it dissolves in water. This example represents a word equation because we're given the equation in words. We don't really get a lot of information from the words. We need to use symbols instead. So first we want to look for where we would have our yield sign. Solid sodium oxide dissolves in water to produce. To produce would indicate my arrow. That means anything that comes before those words would be a reactant. Anything after those words would be a product. The first compound we have is sodium oxide. Now sodium is a metal and oxygen is a nonmetal, so this is an ionic compound. So we want to make sure that we cross our charges when we write the formula. So Na is in group 1, that's +1. Oxygen is in group 16, so it's -2. And we're going to cross our charges, and we would have Na2O. It also tells me that it's a solid, so we can put an S there. Dissolves in means that I'm adding it to my water, so that is my plus sign. And then water you should recognize as H2O. Because it's listed as water, it's a liquid. Then I have my to produce, so I know I'm going to move on to my product side. Aqueous, solid sodium hydroxide. So that's ionic because it contains metal and nonmetal, so I need to make sure that I cross my charges. So sodium is Na and group 1 is +1. Hydroxide is the polyatomic OH -1. So when I cross my charges, I get NaOH. Aqueous means AQ. This is also referred to as a skeleton equation or a skeleton reaction because it is unbalanced. Here I have a formula equation. You would need to recognize the word equation. When you do word equations, you usually say what the substance is, what state it's in, before you say the actual substance. So I'm starting off with solid copper. The plus sign as a reactant, you could use the words reacts with or the word and. Or if the other substance is water, you can say dissolves in. But only if the other substance is water. So here we could say reacts with Ag, or the state is aqueous, and then Ag is silver. NO3, the polyatomic, is nitrate. Now I need a Roman numeral because it's a transition metal. NO3 would be in parentheses. Since I have no subscripts outside the parentheses, the charges are the same. So the charge on nitrate is -1, which means silver is going to be +1. So this is silver 1 nitrate. The yield, or the arrow, we could use any of those words from the previous slide. Yields, produces, forms, turns into, makes. I'm going to use the word to produce. Solid, silver. Now the plus sign as a product, the only word that you can use is and. So this is solid, silver, and aqueous, copper, nitrate. Now copper is a transition metal, so I need a Roman numeral. So I'm going to take that subscript and uncross it this time. So it is copper 2 nitrate. To balance the reactions, we're going to make sure that we have a formula reaction first. We're going to balance polyatomics when they appear on both sides. We're going to balance one atom at a time. And then one of our tips is to save hydrogen and oxygen to last. So for example, I have water, H2O, decomposes into, that would be my yield, hydrogen, and oxygen. Now hydrogen and oxygen are a part of our 7 diatomics, or Hofbrinkel. If you have one of these 7 elements by themselves, like hydrogen and oxygen here, they need the subscript 2. Water, we have hydrogen and oxygen, but they're together, so Hofbrinkel does not apply. To balance, we're going to use the inventory method. You put a line in front of each of your substances. Use the arrow to cut the reaction in half. Look at your reactants. We have 2 hydrogens and 1 oxygen. 2 hydrogens and 2 oxygens. I've listed the hydrogen and oxygen separate on the product side because they're found in 2 different substances. Now hydrogen matches 2 and 2. My oxygen does not. I have 1 and 2. So I need to multiply by a coefficient to get the same number. So what times 2 is 2? 2. Now I can multiply everybody by that coefficient. 2 times 2 is 4. 2 times 1 is 2. So now I have 2 oxygens on both sides, but I have 4 hydrogens versus 2 hydrogens. So what can I multiply 2 by to get 4? 2. 2 times 2 is 4. Now I have the same number of atoms on both sides of the reaction. So this blank would be a coefficient of 1. You don't have to write 1, but you can to fill in that line. So this part right here would be our answer. So we have solid calcium reacts with water. 2 form would be our arrow. Aqueous calcium hydroxide. Calcium is +2. Hydroxide, the polyatomic, is -1. And I cross my charges. And is a plus sign. Hydrogen gas. Now hydrogen is a diatomic, so that should be H2 gas. Place lines in front of all of our substances. Take the arrow, and that's where I'm going to cut the reaction in half. I have 1 calcium, 2 hydrogens, and 1 oxygen. 1 calcium, 2 oxygens, and 2 hydrogens, and then 2 more hydrogens. So my calcium is balanced. I have 2 hydrogens on this side and a total of 4 on this side. So I'm going to multiply by 2. So I have 4 hydrogens and 2 oxygens on both sides and 1 calcium on both sides, so we're actually balanced. So we need to put a coefficient of 1 on each of those lines. And then that would be my final answer. Here we already have the reaction written with formulas, so we just need to do our inventory. 1 potassium, 1 chlorine, 3 oxygens. 1 potassium, 1 chlorine, 2 oxygens. 2 and 3, the least common multiple would be 6. So I'm going to multiply 2 and 3 to make 6 oxygens, and then 3 times 2 to make 6 oxygens. But now I have potassium and chlorine to worry about. So I'm going to multiply by 2 to make it even. So my answer would be all of this right here. Again, we have a formula reaction. To take inventory, I have 1 Li, 2 Als. Now I have SO4 showing up on both sides, so I can treat that as one thing. 3 SO4s. On this side, I have 2 lithiums and 1 SO4 and 1 aluminum. 3 sulfates, 1 sulfate, I'm going to multiply by 3. 3 times 2 is 6, 3 times 1 is 3. 6 lithiums, 1 lithium, I'm going to multiply by 6. 2 aluminums, 1 aluminum, I'm going to multiply by 2. And there's the reaction balanced.